This chapter is about refraction. First, we will have a look at some practical examples for refraction. All are based on light rays. You might be familiar with some scenarios. Afterwards, we will be looking at the theory. First example. The apparent shape of a hand under moving water changes all the time. Second example, a straw in a glass of water. The straw appears in a funny shape where it is in the water. Above the glass, it just looks the usual way. Third example, the edge of the face appears moved to the left behind the right lens. The stronger the glasses, the bigger the effect. Fourth example, the sunlight travels through a lens. The lens allows the light to be focused on one point. Now it is so intense that smoke appears. The examples just shown have one thing in common. At least some rays of light change direction as they pass from one medium to another. For example, from glass into air. To understand the theory, we will now look at a very simple situation with just one ray of light. Here, this ray of light travels from air into a block of perspex, also known as acrylic glass. Then it continues from perspex into air again. When the light leaves the block, its direction changes. This change of direction due to the change of medium is called refraction. In this example, I have an angle of incidence of 40 degrees in perspex and an angle of refraction of 68 degrees in air. Let me draw this situation. This is the boundary between perspex on the left and air on the right. Like in reflection, I'm drawing a normal where the incident ray hits the boundary. Between the normal and my incident ray, I have the angle of incidence. I call it theta perspex. The angle between the refracted ray and the normal is the angle of refraction named theta air. Now I will reverse the direction of the light and let the ray travel from air into perspex. If I choose 68 degrees as my angle of incidence in air, I obtain 40 degrees as my angle of refraction in perspex. So the first observation is that the direction of the ray has no impact on the angles in the two media. What does have an impact on the degree of refraction is the refractive index N. The refractive index is a property of the material. It typically ranges between 1 for vacuum and about 2.4 for diamond. The refractive index of air is very close to 1 as well. The higher the refractive index, the optically denser the material. So diamond is optically denser than perspex. This is a PhET simulation that allows me to change the refractive index and to observe the effect on a refracted ray. As the material at the top, I choose air, and for the lower part I select glass with a refractive index of 1.50. Here I can turn my ray box on and I can change my angle of incidence. You see that some light is reflected and some is refracted. As before, we will focus on the refracted ray. I can have the normal shown to me and I can use this protractor to compare my angle of refraction for different materials. I can use this slider to change my refractive index which means changing my material. So if I move the slider to the left to have water, my refractive index decreases to 1.33. My angle of refraction has increased. If I reduce the refractive index further, my angle of refraction increases. Finally, when I have a refractive index of 1 at the bottom, my ray of light travels in a straight line as the top and bottom have the same index of refraction. When I increase the refractive index again, then my angle of refraction decreases. So the second important thing we learn is that the higher the refractive index n, the greater the degree of refraction. Now we come to the third and last point to note. You have seen this already, but I just want to point it out to you. As a ray enters a medium of a higher refractive index, it is refracted towards the normal. If it travels into a medium of a lower refractive index, it is refracted away from the normal. So, let me summarize. In a nutshell, number 1, refraction is the bending of light when it travels across the boundary between media. Number 2, the angles in each medium are independent of the direction of the ray of light. And number 3, as light travels into an optically denser medium, it is refracted towards the normal.